hope everybody's ready for a little fun. Don't everybody jump up and down at once, because if you're not ready for fun, you're in the wrong place. Okay. So we're about to go through an interactive exercise. We're going to have a little help from our application engineering team. And so to start things off, you heard about how knowledge aware and the technique of doing this is very broad and enterprise in nature. I mean, you can literally plug this thing just about anywhere in a discrete manufacturing company. And because of that, it's not uncommon for people to feel a little overwhelmed and bewildered when they're first introduced to this brand new idea. So, that being said, it's actually very, very straightforward to transform a traditional process into this knowledge-aware process. And so we wanted to design an experience for people who are brand new to this idea that would be fun, collaborative, and painless, and easy to absorb, okay? So bear with us while we get through this exercise. I think you're going to have a lot of fun with it. Prospective customers, people that aren't engaged in Auros already, this is a warm-up exercise for all the presentation material that you're going to hear tomorrow. And for existing customers, we hope this is something you can take back home with you to help onboard other communities that you think could also benefit from what Auros can do for them. So the exercise that we're going to run through is just one use case scenario. We talked about that there's a lot of different use cases for this thing. In live customer production environments today, we're anywhere from all the way up front in the concept development and clay modeling studios through design reviews, engineering sign-offs, deviations, quality, operations, plant health, general business processes, how to install and maintain equipment, et cetera. So that footprint keeps expanding because people keep finding new ways to apply this knowledge-aware technique to what they're doing. So, enough talk. On to the exercise. Everyone here in the room is going to change roles for a couple minutes. You've all just become employees of the Cool Cup Company. And we make cups, lots of them, right? There's different materials, there's different types of colors and sizes. We'd like to stick to our standard product offering, but every customer that we do business with likes things a little bit different, so we've got all these one-offs that we always produce, right? We've got some albatrosses that have come to light based on past experiences and kind of messing up a few times along the way, and we have a deluxe model for the premium market, complete with thermostat on the side, okay? Now, we've got a brand new customer who's come to us, and they've got this fantastic idea. They've got this market analysis, and they want to produce this new cup, and they want us to make it. This fantastic, beautiful cup that they have this idea for, and they've given us a list of requirements. Now, one of the key concepts that we talked about with knowledge-aware engineering is the idea of a knowledge packet, a single unit-based morsel of goodness that describes the how and why we can do some of these things. It could be a best practice, a lessons learned, it could be a rule, it could be a design requirement, it could be a manufacturing specification. The list goes on and on. There's an infinite number of what these things can be. But again, they're going to describe the how and why we can meet those different requirements. So, with the help from the application engineering teams, we're going to have teams assume different roles within the process. So this section over here is going to become our product engineering team, okay? And so we're going to have rows 1 and 2 collaborating with Chris. You're going to see that he's walking out with some materials over here, a cup and a storyboard. And it represents a stage gate, right? The traditional stage gate process. And so the job of the design and product engineering team is to come up with a cost-effective and manufacturable concept that meets the customer requirements. Now, rows 3 and 4, you're going to be working with Jimmy. And so I'll get back to what your task is going to be here just in a second. The middle section here, you're going to be manufacturing engineering. And you're responsible for making sure that we can physically produce the stuff that they're coming up with, okay? And so rows 1 and 2, you're going to be working with Josh. Rows 3 and 4, you're going to be working with Kurt. And then over here, we're going to have our quality group, responsible for all the quality aspects at the corporation. Rows 1 and 2, you're going to be collaborating with Steve. Rows 3 and 4, you're going to be collaborating with Sean. And so the idea that we're going to do here is, again, you'll see the materials that they're coming out here. They've got some colored dots. They've got some sticky notes. They've got a stage gate process. And so what we want to do, the application engineers are going to be your scribes on your team. They've got the sticky notes. They've got a pen. And what we're asking you to do is come up with a minimum of 5 ideas for what a knowledge packet could be about making a great cup, or designing a great cup, or maintaining the quality aspects of a great cup, okay? And so 1 idea per sticky note. Please try to make at least 5. We expect that some of you might come up with more. But we're going to take about 12 minutes to get through this part of the exercise. And as you're coming up with those ideas on those sticky notes, I want you to place them along that stage gate chronologically that would represent where you think that that piece of knowledge would first be represented when somebody should first become aware of it, right? Either evaluated by your team, or you need feedback from somebody else's team, or even feedback from a supplier, right? So there are no right or wrong answers here. We're just completely spitballing this thing. And the idea is, let's make some knowledge packets just in concept on some sticky notes. So we're going to set the timer for 12 minutes and wish you the best of luck. And so now what we're going to do is we're going to take those stage gates and we're going to bring them back to you so you can see what you started with and what the teams thought about what you had written. Okay? So let's take those stage gates and move them back to where you started. And let's take a look at, was your knowledge authored so that other people could use it? So what we're going to do now is we're going to take those things all to the back of the room and we're going to combine them all on a single board. Okay? And so while the team is doing that, let's take a minute to reflect on what we've just been through. So number 1, as opposed to going off on a dissertation and authoring a gigantic volume of work that you can even share some stories I've heard recently with customers who say, look, we've got this huge document and somebody wants to make one revision to it and the thing gets caught for 2 years because nobody can decide on that one concept that needed to be updated, right? Now we're breaking it down into discrete pieces. Single concept, single idea, it's unit-based, right? It should have been fairly easy to create, right? So a lot of customers start off by making knowledge packets that don't have rule processing in it. It's a simple question of, did you evaluate this? It might be a yes or no, as opposed to parameterization or a boundary condition that they want to set on one of these things. Managed and organized by stakeholders, right? These knowledge packets ask for your participation. If you're not participating, the knowledge packets know it. They provide live feedback. And the visibility and the visualized demand for the knowledge, right? As an author, you get feedback from other teams. Are they using it? Are they evaluating it? What do they think about it? So these are some of the key ideas behind what a knowledge packet is going to do. And then we're going to move into, as we start to kind of build this out a little bit from the concept to, hey, how can we make this happen with a tool? And start, we have a shiny toy called Auros. We love to show it off, and sometimes we do it too much, and we overwhelm people. And that's part of the idea behind this exercise is like, okay, let's try and do something that people can maybe relate to the concept of breaking it down into bite-sized nuggets, getting feedback, showing the participation of how it makes its way around and how it's engaged upon by the other teams. So what we're going to do now is we're going to bring that thing up here and we're going to turn one of those knowledge packets into, or one of those ideas, one of those sticky notes, we're going to make it into a knowledge packet. So we're going to turn it over now to the engineering team who's going to walk through some demonstration work with you. And if we could take a minute to please open up your app and fill out a survey on this exercise. We'd really appreciate your feedback. This is the first time we've done this with a group this big. We've done it with a smaller group, but certainly this is a much bigger audience than we've tried this thing with. thank you for participating. We really appreciate it.
Yeah, Jeff had the hard part. I get the fun part. My colleague Evan and I here get to now take the morsel of knowledge that you guys put, or a morsel of knowledge that you guys put into the flow of work, kind of. This is kind of a visualization of a flow of work. And we're going to turn it into a knowledge packet, because one of the things we like to convey is how different a knowledge packet experience is and how it interacts with its environment than a document. And the first step in creating knowledge packets, as the video indicated, is to decompose into bite-sized units, but then we can elevate with this encapsulation we call a knowledge packet. So I'm going to come over here and randomly take, so to speak, one of our authored morsels of knowledge, and this one is from Design Verification, and it is the fluid egress hole must be 2 centimeters, and the air vent diameter must be 25% of the egress hole. Okay, so to get fluid in and out of a closed container, right, we need to pour it out of one hole and we need to allow air into another. I'm assuming that's what this is all about, right? So I'm going to ask my colleague, Evan. Brittany, can we switch over to Evan's computer? And we're going to use the Auros technology to elevate this morsel of knowledge into a knowledge packet, okay? It's a pretty simple process, reality. So Evan, we're looking at a series of communities on an Auros demo site, and we're going to go into the series of communities under the Cool Cup company. And Evan, this one is product design I think we pulled it off of. Can we go, yep, let's go into product engineering, and we're going to go ahead and create a knowledge packet there. Typical kind of engineering concept though, right? I mean, a pretty performance kind of design, engineering design standard. Seems familiar to everybody? Yeah? Okay, so we have our Cool Cup series of communities. We go into community. There's a few knowledge packets already here. We're going to incrementally contribute to this knowledge base by adding this new product standard. So Evan's going to go ahead and select Add New. And he's presented with a couple knowledge templates. Of course, Auros provides a bunch of knowledge templates out of the box. And then there's an infinite ability to customize these templates. And we're going to go ahead and create a new engineering standard. And we come up with the Auros WYSIWYG editor for creating these knowledge packets. The first part of this is really basic. It's an engineering concept. Let's give it a name. So let's call it Performance Criteria for Fluid Egress. Okay, and just for efficiency, go ahead and copy that, and let's just add that to the description. So what people read, people recognize, they'll get a unique ID, so that we can always refer specifically to this concept. So go ahead and add that to the description too. Of course, we could, if we were an expert in this, we could actually put more description here. And let's add some images just for the fun of it. Let's add an image section. Let's go ahead and double click. Let's take one out of our image library. Yep. Okay, and now, that's pretty basic, right? You do that in a document, that's not a whole lot different other than we're really focusing on an engineering concept, and that concept has a unique ID. But so far, not so much different. But let's take this now to a whole new level. Let's start talking about deterministic forms of knowledge. So Auros provides many different ways to convert knowledge into something that is going to create an interaction model with its environment. Okay, this is what models do. They interact with their environment in a predictable way. So how do we take knowledge like an engineering constraint like this and do that? So one of the techniques we have is called a value table. This one is perfect for that. So what we're going to do, let's go and let's edit this value table. And those of you familiar with value tables, I mean, we have some customer experts here, trust me. We have some people who do amazing things with value tables. You'll probably see some examples tomorrow. And we're going to go ahead and create this. So the first thing you notice it's set up as a table. This is a column that represents a specific kind of relationship. So there's two relationships here, not just one. So can you create two columns, please? Okay, now we got two relationships. So the first one is the egress hole. Must be 2 millimeters or greater. Okay, let's say it has to be 2 millimeters. Okay, that's the hole size we want. So let's go ahead and say nominal egress hole diameter. Okay. And let's make it a type nominal. There we go. And let's say 2. And it says centimeters, so let's go ahead and put centimeters. That's a big hole. You guys are thirsty. Okay? And let's go ahead and give it a pretty parameter name, please. So let's call it egress underscore diameter as a local parameter. Tomorrow we're going to be talking a little bit of systems engineering, and we're going to talk a little bit about global local parameters and how we can create automated traceability maps across parameters. Very cool stuff in version 8 of Auros. And let's create something called what Auros calls an end user message. Evan, let's just click on it and create the default end user message. Just pick that. So it's a nice way for experts to communicate. I mentioned this becomes a communication tool. It's not a new thing to do. It's the way stakeholders communicate. And we have a bunch of really important features that improve that communication, will make experts want to communicate this way. Okay, so let's go to the second column, and let's call it nominal vent diameter. Nominal vent diameter. Okay, and let's call it, and it's 25%, so 0.25. Oh yeah, nominal. Let's do a nominal here. And let's do 0.25 times, and let's take the parameter name of the other diameter. What is it? Egress diameter. Now we're using local parameters here, but these can be, Auros has a very nice global parameter naming library mechanism. Okay, and let's give it centimeters as the units. And we can also just use the default end user message, Evan. So the very simple technique, but those of you who are familiar with it know that this grammar extends to very, very complicated scenarios, interweaving different parameter cascades, introducing conditionality, doing text processing. This one's kind of a CAD-like thing, but it works for attribute stuff as well. Okay, so that's it. What have we actually done by doing this? Let's hit save. Okay, the first thing we've done is we've added something visually consistent across multiple authors and representing numeric boundaries. This is a numeric boundary, it doesn't have to be. Think about the power of that alone. All your documents out there and different authors writing these same kinds of constraints over and over in different ways. Here you are an end user, and you're going to that document, it says it in a string, and that document it's in a picture, and how are you going to process all that? Doesn't happen. So the experts don't wind up communicating that way. Here now we have a consistent visualization of that relationship. But that's not where the real magic is. So let's go ahead and save this. Oh no, let's scroll down, let's look at the metadata. So we have this attribute section, which is, as the existing customers know, extremely flexible. And the first thing it's asking us is, let's go cup type. Let's go ahead and pick a cup type. Team, what was this? A deluxe cup? Was it a deluxe cup? Let's say this applies to the deluxe cup. Yep. And then let's pick, this applies to what stage gate? Let's say it applies to design, no, it came from design, yeah, let's look concept design, that's fine. Concept design, design verification, whichever where the sticker pulled it from. 2. So only from design verification? Okay. Okay. So take that off the first one, okay? Doesn't matter, we can pick one, multiple, and hit save. So now what we've done, to go back to that original kind of concept from this morning, is we have a provisionable nugget of knowledge that can be connected to the flow of work, evaluated in a way that affects decisions, and everybody can see that happening. This is starting this engine of now it's not an off process, it's a communication process. So let's emphasize that point a bit more. So now we're going to talk about the assessment control. We haven't seen those yet. So what we're going to do is we're going to create a basic one. We want to integrate knowledge into the flow of work in this design phase. So we're going to do something really quite basic. Let's go to search by filter, Evan. And our context here, very simple, is a deluxe cup. And we are going to seek and integrate the knowledge that has to do with the, what phase was it, Josh? 2? Design verification phase, fine. Okay, so now we're gonna work with the metadata that is on every single nugget of knowledge. Go ahead, hit search. And we have some knowledge to consider. So we're gonna create an assessment control out of this knowledge. So Evan, let's go ahead and go to the build menu and build an assessment, okay? So we are going to, what does it say? Oh, at whip, okay. We didn't save it to active. Oh, we did? Oh, okay. All right, just go ahead. Since he's an author, it automatically included with, yeah, these guys from Navistar know because we talk about this all the time. Okay, so what project are we in? This was the Max. So go ahead and pick the Betamax, yep, and generate the assessment. Now, for those of you not familiar with assessment controls, we just went the longest way possible to create assessment. That was the hardest way to do it. Or the technology that Auros has many ways of automating that process. In fact, there are certain work processes where as many as 1,000 assessments get created and signed out in 10 minutes, and they're all customized for specific design events, okay? So it can be done. If you don't mind collapsing the left. So what this assessment control is, and if you look in your glossary of terms in your actual things, it has a technical definition. It's in your little books. Technical definition is a tool set, comprehensive tool set for processing knowledge in the flow of work. So now we've got rows here that represent knowledge. So I believe the one we just authored should be here, right? So there it is, product engineering 12, and there's even a quality one. Some quality person has authored something, and it showed up in my flow of work. That's interesting. But let's concentrate on this one we just authored. Can you go ahead and click and open that? Okay, now we can visualize the whole thing. Pictures, who did it, when, why, all that stuff, the metadata. A lot more power here we won't get in today, but let's talk about this interaction model. So let's close this. Now, we're going to interact with this knowledge. We could just say, in the traditional way, okay, I've read this, I pass. So go ahead and say pass. Okay, everybody knows that's a low fidelity event. When you ask an engineer or somebody who has to consume a lot of stuff, you get a low fidelity. You're asking him the same question, doesn't matter what the knowledge is, you're asking the same question over and over. Pass or fail, pass or fail, pass or fail. Everybody knows that's a low, you're not going to get good results. But when you deepen the interaction model, there's a couple things you can do. So we didn't just create a text document, we actually created a deterministic model of the knowledge you just put in this paper. So let's go ahead and click on the lightning bolt. This question now is specific to this idea of how the fluid is going to flow through these holes. It's asking me, what diameter do you have? Okay, so let's put in 4. And we forgot to name the other parameter, but that's okay. So let's put in 4. That's the egress diameter. So go ahead and put in 4. Go ahead, 4 and 4, yeah, that's good. I'm failing. Now my interaction is with these specific criteria. There's no ambiguity now in the communication. The expert is telling me specifically, and it's saying your egress diameter should be 2, but it is currently 4, fails. Now there could be a lot more information. If it's more than 2, you're going to get too much fluid. Less than 2, you're going to get too little fluid. Whatever the expert wants to convey. Now the expert is getting benefit because the expert doesn't have to go tell the person every time, right? And it's communicating right into the flow of work, right when the person is doing the communication. Okay, it needs to be 2. So Evan, can we go ahead and change the egress hole to 2? You also notice that the status, where we were initially asked to attest, now is actually being filled out based on the specific interaction. Okay, so now it's 2. Let's hit resolve. Okay, we've improved the situation. But now it's saying, hey, should be 0.5, because it was 25% of the whole, and it is currently 4, and it fails. Oh, all right, I can fix that. So let's go ahead and make it 0.25. Resolve. Oh, I'm sorry, 0.5. My bad. Green, green, green. So what you're seeing is a more deterministic interaction. You're seeing a level interaction. And what you're not seeing here that you will see tomorrow is you're seeing an interaction that can be highly automated. There's no reason to hand jam these values in. They can be imported, they can be connected to your modeling environment. How many people would disagree with this statement? The engineering environments are becoming less digitized. Who's gonna agree with that? Right? We all know that engineering environments are becoming model-based in digital environments. Parameters are known. It's just about making the connections. Establishing a way to represent stakeholders' points of view that are digital that can then be connected with those environments. That's what we're doing here. Now, if you saw this happening and you knew your cup was going to come through this process and you learned something about how to prevent hot liquids from falling on your customer to save your company the next major lawsuit, how are you going to communicate that to your organization? Now you know you just created a knowledge packet. It becomes the communication. It's not, oh, I got to write a lessons learned I know no one's going to read. It's not, it's going to be in a checklist that attestation is just people are going to gloss right over it and never read it. Now, and you're not seeing it all yet, but this is all, the intelligence part is going to get wrapped on top of this, magnifying this impact. This is the state of the art. Not databases, not requirements. This is where it's going. Your environments get digitized. Knowledge needs to be created in deterministic models. It needs to be a communication, not a separate process. It'll be fundamental to the way we design products. Okay, that's it. That's kind of hopefully now bridging, hey man, these are knowledge packets, these are assessments, and this is knowledge-aware engineering, and hey, we want to have technical memory. We want to have learning organization. We want to have effortless recall. Now, hopefully, you're seeing why these kinds of technical features produce recall, produce technical memory. Technical memory, because as soon as it's communication, that's where the stuff is going. It's accumulating. There's lots of tools to keep it fresh, to keep it refined. And the effortless recall, you start to process rules. You start to connect to the digital environments. Now it's effortless to know whether that vent hole is of the right size. Right? I mean, do you really want to have someone in CAD checking that hole, and every time there's a revision, they got to go recheck? No, it should be connected to knowledge, and it's checked continuously as that model evolves. Now, that's easy to imagine in digital CAD kind of world, but it works equally well outside of CAD. It works in manufacturing models. It works in process models where you're talking about sequences of stuff. This is just a product design example. Brian, how are we doing on time? We're good? Okay, that concludes the exercise. Now, it was the first time, as Jeff said, it's the first time we ever did it, and hopefully now we've seen the full circuit of it. And again, it's available. We can take this, you can do this exercise, we can give you the tools, or we can come and help you do this exercise if you think this is a good way to explain what knowledge-aware engineering is all about back at your companies. So do take the survey. Yes, we have a question. Thank you. Break the ice.
Are not empowered to just add things to databases, and there's approval processes for all that. So how do you guys handle that? Especially, I think we've talked to Jeff at Navistar, or how do you just let anybody add to a knowledge? We'll need a committee.
Yeah, so that's a great question, and the answer is actually quite straightforward. Auros, last year I hit this a lot harder than I did. Is a bottom-up system. Bottom-up organic means every group has got a different need specific to the need of approvals. Communities, based on who they are, can be set up to have rigor or lack of rigor in publishing content, okay? So if you are the FMVSS community, for those of you non-automotives, this is government regulation, right? You don't need to go get 10 people's approval. You need to synchronize with what the government says, and that's it, right? I mean, there's no shades of gray here. It is or it isn't. So you can have a single person synchronizing with FMVSS. It's not that big of a deal. You may choose to have a community to be a feeder community. We see this every once in a while. And a feeder community allows everybody to come and create knowledge packets. Then you can elevate or move knowledge packets from one community to another. And then what happens is that elevated community can have rigor in its publishing process, right? So, I mean, GM has a big enough footprint. You probably have all manner of approval processes. Some are very closed. Some are very open. It's true for access control, too. Who can see it? Some need to be open. Some need to be, hey, man, you need to have the letter T twice in your name if you're going to get in. I'm making a joke there, but not a very funny one, obviously. So the answer to your question is you cannot predefine it. It changes all the time. And Auros uniquely allows you to adapt at the community level and change what the community's needs as the community needs to change them. Right? If you need to ask IT to have a project to change that kind of stuff, you're host. Now, I'm not going to pick on the PLM folks, because there's probably some PLM folks in the room, but one of the failure modes of PLM and people trying to do custom stuff in PLM is it requires programming all the time. You can't get the job done. As soon as you specified it, you've sunk the money, then you go to production with it, and things have changed or you didn't specify right, and you can't do it. You need something that allows quick and rapid prototyping and iteration and adaptability, and that's what we mean by bottom-up. And there's a good definition of bottom-up in their pamphlets, too. Great question. Thank you. Come on. Ice is broken now. Someone's got a question. Okay, the next thing is break. Brittany, am I correct? Break? Okay, so we'll take 15 minutes for a break, and we'll come back and we have the Farbulator Company series of narrative here for us.